Now that we've read over the first part of section 19.4, we're going to go ahead and take some notes to put that information about earthquake hazards in our notebook. But we haven't recapped what we should have in our notebook for a while, so I thought it might be a good time to do that. These are the stamps you should have had or been close to having before we left school on the 16th. There were 5 of them, so hopefully you still have these things if you didn't get your stamps before the 16th, because these are still going in the grade book as regular school day points. Then you should have your stress concept map. That was also from before we left. You should have cut the picture or the graph off of the stress strain worksheet and put that in your notebook. You should have your false notes in your notebook from before we left. You should have your false foldable in your notebook from before. We also did that before we left. And the earthquake waves foldable with all of your information about P waves, S waves, and surface waves. That was also assigned before we left school. Since then, we have taken notes on seismometers and seismograms. We have taken notes on how earthquake waves pass through Earth's interior. You were supposed to cut out the diagram for that worksheet and put that in your notebook. We took notes on the different types of earthquake scales and how they can be measured. And that intensity is still part of the earthquake scales notes. Then we talked about how you find an earthquake's epicenter, and you were supposed to cut off this diagram from that worksheet and put that in as well. And the seismic belts were still part of those notes from 19.3. And today we are doing notes from the first part of 19.4, earthquake hazards. So perhaps we should start with a definition, and I'm going to abbreviate earthquake quite often in these notes as just EQ. Earthquake hazards are factors that determine the severity of the damage of an earthquake. So, for example, the design of buildings can have a lot to do with how much damage they sustain during an earthquake. In the chapter, it talked about brick buildings and concrete buildings versus wood. Those brick and concrete buildings are often called unreinforced masonry. Unreinforced masonry buildings are those that are made of brick or concrete, and they're unreinforced, meaning there's no other structural support there. If you're familiar with how concrete structures are put together, a lot of times that concrete is fortified or strengthened by putting a grid of iron bars in it. It's known as rebar. That would be reinforced masonry. Unreinforced masonry is where you just have the concrete or you just have bricks and you don't have any other structure that helps support those materials. Unreinforced masonry cause the worst kind of damage. Well, not really cause, but they result in the worst kind of damage from earthquakes. because there's no give to those structures. They just crumble and break. Wood structures, on the other hand, like houses, tend to be more resilient because wood naturally has a little bit more give to it. So as the house is swaying from the shaking underneath, the wood doesn't necessarily break. I mean, eventually it does, but it's got a lot more give to it than like concrete and brick. So the materials that you choose to build your buildings out of can have a big effect on what kind of damage you get. Depending on what kind of materials you chose, sometimes you see a special kind of damage known as pancaking. And pancaking is just like what it sounds like. That's where it got its name. Pancaking occurs when the walls of the ground floor, so talking about a multi-story building here, when the walls of the ground floor fail, which causes the upper floors to fall. So those upper floors smack down on the lower floors, and eventually at the bottom you just have a stack of floors with no walls in between them, and it looks like a stack of pancakes. So that's why they call it pancaking. Another thing that can happen with earthquakes, depending on the size or the height of your building, is known as resonance. The text that we're using didn't use this particular vocabulary word here. They will use it later in the second half of 19.4, but they talk about it here. So we're going to go ahead and introduce that vocabulary word, resonance. When the height of the building matches resonance is when the height of the building matches the frequency of vibration of the earthquake. What this causes is more swaying or more violent swaying of the building. When the frequency of the vibration of the earthquake waves matches the height of the building, that causes the building to shake more violently. The phenomenon of resonance also occurs in sound. If you have ever been in a building or an auditorium that's said to have really good acoustics, it probably takes the sounds that are being produced by the artists in that building, and in the frequency of those sounds causes the building to what's called resonate. And so that makes the sound seem that much louder and that much more amplified. So resonance occurs when the frequency of a wave matches kind of like the container that it's going through. And with an earthquake wave, that can cause your building to sway a lot more. You can also get landslides. So all of these things are earthquake hazards. Probably you have a pretty good idea of what a landslide is. So we're also just going to put here that landslides can also cause damage. I don't think we need a definition for what a landslide is. Another earthquake hazard is called soil liquefaction. Soil liquefaction usually occurs in sandy soil. So sandy soil that is nearly saturated. Saturated means full, so nearly saturated with water can behave like a liquid during an earthquake. Causing landslides, sinking of houses, and rising of pipes to the surface. Soil liquefaction occurs when the ground is being shaken so much that the whatever liquid it's holding kind of takes over the properties of the soil. So soil liquefaction is when the soil behaves like a liquid. And so then, as you can imagine, a house might sink, or pipes that were buried underground might rise to the surface, and it can cause a lot of damage. Soil type is another thing that we put under our list of earthquake hazards because it affects how damaging the earthquake is. Now, I mentioned this when I did the reading. Your textbook indicates that bedrock or solid rock amplifies earthquake waves and is worse than soft sediments, but every resource that I have checked on the internet seems to indicate that the book got that backwards. So when we're doing our notes here today, we're going to do that differently than what the book says. So bedrock is generally safer than sediments. Which can amplify shaking. And again, that is different than what the textbook says, but I have checked several online sources at this point, and they all seem to agree that this is opposite of what the textbook indicates. Okay, the last earthquake hazard that we read about was a tsunami. You probably all know what this is as well, or at least you have a good idea. A tsunami is a large ocean wave generated by vertical motions of the seafloor during an earthquake. And we're going to make a few notes down here as to why tsunamis can be so dangerous or what properties they have. It's important to remember that the waves are very short when they're still out in the open ocean. So it's not like these monster waves cross the entire ocean. When it's out in the open ocean, a tsunami wave is less than 1 meter tall. That's about a yard. So it's no taller than any other wave at that point. But when they get near shore, all of that energy with a shallow water depth can form huge breakers. And they can actually exceed or be greater than 30 meters. That's taller than the second story of most buildings. So near the shore, they can get very, very tall. And they move very, very fast. So it's hard to be ready for them. By the time you know that there's an earthquake that has occurred, and then that tsunami has traveled, I believe it said 500 to 800 kilometers per hour, it can be difficult to get everybody warned in time to get out of the way. Okay, we will finish up section 19.4 tomorrow. We are done with our notes for today.